Hello everyone, this is pulley and wedge system. There are two pulley, this pulley and this pulley, and this pulley is movable pulley and this is non-movable pulley. This block has mass m1 and this block has mass m2. Okay, so now mass m2 is given to be eta times mass m1 and we have to find out the acceleration of both the blocks. Let's do this question. Suppose this pulley over here goes down by x amount. If this pulley has gone down by x amount, this string will go down by x amount, and as a result this string will also go up by x amount. So the mass m1 will go above the plane as by x amount. Now you look at the block m2, right? Now if this pulley has gone down by x amount, here the x amount is reduced and here also the x amount is reduced. That means total 2x amount is reduced, which will be translated in this displacement of m2 block 2x downwards. Okay, because this string here is fixed, right? So all the 2x displacement will be in this direction by this side of the string over here. So if I consider the acceleration of block m1 as a, then the acceleration of block m2 as 2a, right? I double differentiate that. Okay, now let's assume the tension over here is T. If the tension over here is T, then tension over here is as well T. Now what about this string? So there are two tensions over here. One is this tension and this tension. So let me draw the free body diagram of this movable pulley. So this is upward tension T and downward tension is T dash. And this is also T dash because both are the same string. So here you can see 2T dash downwards minus T is equal to mass of the pulley into acceleration. Now the pulley is massless, so I can say 2T dash is equal to T. This is my another equation. This is my first equation. Okay, so let's find out the acceleration. Let's draw the free body diagram of both the masses. First, let me draw the free body diagram of m1 mass. Okay, so we have m1 mass. The tension is upwards the plane like this. This is m1g, and then there will be the component, right? So this is angle theta. So this component will be m1g cos theta because this angle is theta, and this component is m1g sin theta. Since I have drawn the component, I should erase this m1g vector. Okay, so now what I will get, T minus m1g sin theta is equal to m1 times a. This is my first equation. First equation for the first block m1. For the another block m2, what I will get here is that let me use yet another color, blue color we will use for m2 block. So for m2 block, you can see the block like this, m2. The upward tension is T dash, downward force is m2g, and there is another there is a acceleration of 2a downwards. So this will become m2g minus T dash is equal to m2 times 2a. This is my second equation. So instead of T dash, I think I can write T by 2. Okay, or otherwise you can say T is equal to 2T dash. So you can change the first equation. So let me write this first equation here as 2T dash minus m1g sin theta is equal to m1 times a. Is my third equation. Now what if I multiply the second equation by 2 on the both sides? So what I will get is 2m2g minus 2t dash is equal to 4m2a. This is my fourth equation. So let's add this third and fourth equation. You will get 2m2 minus m1 sin theta. I am taking g common. This will become m1 plus 4m2 times a. So the acceleration becomes 2m2 minus m1 sine theta into g divided by m1 plus 4m2. Now the value of m2 has been given to be eta times m1. You can see here eta times m1. So let's put that value. A is equal to 2 times eta m1 minus m1 sine theta, this multiplied by g divided by m1 plus 4m2. So you can take m1, okay, m2 can be written again as eta times m1, eta times m1. So you can take m1 out. So this will become 2 eta minus sine theta upon 1 plus 4 times eta into g. This is m1. This gets cancelled, and thus the acceleration is 2 eta minus sine theta upon 1 plus 4 times eta into g. This is the final answer.